All right, so lesson 1.2 of chapter 1, which is some patterns in nature and regularities in the world. So in this lesson, we would try to define regularities, patterns, and patterns in nature and uh, provide some examples of different patterns that we can see around us. So, um, So, as we all know, when we talk about patterns, we're also talking about counting. So, when there is a pattern counting occurs, there is a reason when there is counting, reasoning. As a result, in nature, patterns corresponds to logic or logical arrangement. A specific pattern has its own characteristics. So different patterns or not all patterns are the same. So they have their own identity. They can be unique from one another. Okay. So some individuals learn, discover, and understand these patterns. They were able to look for connections and how does these patterns can be used to explain and describe real world occurrences or phenomena. So most people believe that mathematics is all about patterns. So just like patterns in nature, mathematics can be everywhere. So patterns can be in different shapes, sizes, appearances, just like number patterns or number sequences, wherein you have a set of rules. It can be a sequential or in order. It can be spatial or visually. It can be temporal or even language has patterns. That's why Ian Stewart mentioned that we live in a pattern-filled cosmos. Because of that, our human mind, our brain, and culture was able to develop a system in order for us to recognize, understand, comprehend, classify, and use those patterns. Okay, so we call that system mathematics, according to Ian Stewart. So the question is, why do we need to study patterns? Patterns are ways on how we can identify relationship, find logical connections or rational connections between the natural world so that we can use it to come up with generalization and make predictions. That is according to our source. Now, Collins in 2018 mentioned or defined four terms when we talk about patterns. First one is regularity. The same things will happen if we have the same circumstances. Okay. Then from those regularities or things that occurs all the time, we can look for patterns or regular occurrences. It can be in a form of repeated objects, recurring forms, or even designs. Patterns can be in a natural world or man-made, such as number patterns, which involves numbers. Okay, so these are some example of patterns. Okay, so the patterns of the stars, weather seasons, the cycle, winter, spring, summer, then fall. On the snowflakes, we also have the animal prints, zebras, lions, cats, and snake skins. No, normal phenomena such as ocean waves, typhoon formation, or even plant leaves, they have patterns. So what are the different kinds of patterns? Now, Patterns can be classified either symmetry, fractals, spirals, tessellations, cracks, even the animal stripes and spots, or even bubbles. Okay, so those are patterns. So symmetries are in mathematics. When we talk about symmetry, these are such like when you move some object, one form becomes exactly like the other form. Like if you flip, you cut, or you slide the object, it seems that it is identical to the original form or to the other part. Just like looking at a mirror. When you see your reflection, that's symmetry. Okay. So in everyday language, in other words, when we talk about symmetry, no matter the form that you do, they would have the same exact image. So there are actually few types of symmetry. So these are example of symmetries. Butterfly symmetry, if you cut the butterfly into two, the left and the right side are equal. The different shapes, the kite, if you cut it into two, the hexagon, the trapezoid, the rhomboid, or the slanted square, a triangle, or a rectangle. Now, symmetries can be a vertically, horizontally, or diagonal method. So these are the types of symmetry. We have bilateral, wherein if you cut, fold the object into two parts, the left side or the right side are equal or exactly the same for the upper part and the lower part. Then we have the n folds. Examples are the three-fold, again, three symmetrical faces, five-fold, five symmetrical faces, six-fold, six. Now we also have rotational and or radial symmetry. So in a rotational or radial symmetry, unlike bilateral and n folds, you cut them or you fold. In a rotational symmetry, from the name itself, rotational, you rotate the object. Okay, so it is a property of a shape when it appears the same after any rotation by a partial turn or a full turn. Okay, so it means that if you rotate the object at a certain position, it seems that it's on the original position even though you have rotated it already. So we have what we call order of rotation, wherein uh, the number of rotations can be done. Okay, so the number of rotations will depend on the number of sides of that particular object. So the question is, on what degree measure, or exactly how do we measure the rotation, the exact rotation or degree, in such a way we would achieve the original position of the object. Okay, so we have what we call rotation angle, and that is 360 divided by the number of sides of that figure that we're talking about, like a star, or this is an example of a rotational symmetry. Okay, so you would notice that on a certain degree angle, if you rotate it, it seems that you are on the original position. We also have the square, uh, another one. If you rotate it, this one, you have the same. Some other examples on how to compute is, again, as I mentioned, that's 360 divided by the number of sides. Starfish with 5 legs. So that's 360 divided by 5, 72 degrees. So every 72 degrees that you rotate the starfish, it seems that it's on its original position. A snowflake with 6 sides, that's 360 divided by 6, so every 60 degrees. Another pattern is fractals. So these are never-ending patterns. So there is a forever. Okay, so it is a infinitely complex pattern that are self-similar across different scale. So no matter how you zoom in or you zoom out that object, it is the same image that you see. Okay, so that is a fractal. One good example of a fractal are the trees. Okay, so these are natural patterns because as you can see, uh, every three branches is a copy of one that came before it. From the trunk to the tips of the tree, you would notice that they have the same shape, the same angle. Uh, that's uh, natural fractal, as well as like the leaves of a fern. So it's the entire leaf is in triangular form, and each leaves on that stem is in triangular form, and each of the leaves have smaller leaves that are in triangular form. Then we also have spiral patterns, or by the way, these are fractals. These are natural fractals, and these are geometric fractals. These are the one that are that was studied by Bennett Mendelbrot in order to innovate and develop graphics of our gadgets. Another example. Next one is spiral. So a spiral is a curved pattern that focuses on a center point, and a number of circular shapes that revolves around it is what we call a spiral. So we can be a spiral inwards or spiral outwards. Okay. The next one is tessellations. When a shape is repeated over and over, covering a certain place or area without any gaps or overlaps, we call it tessellations. Just like the natural tessellation, which is the honeycomb. Okay, so another tessellations. So honeycombs, as they say, when you observe it, it forms and establish a tessellation to maximize the storage. Okay, to so that they would be able to storage more honey on their hive. Okay, so geometrically, they are geometrically perfect. Okay, and the concept of honeycomb was used uh, for optimum methods of storaging system, also known as the packing problems. Okay, so to optimize these methods, they are in hexagonal formats wherein you could use available space. Uh, this is tessellation. Next one is we have crack patterns. These are linear openings that forms to relieve stress in a material. Okay, so the separation of an object or material into two or more pieces under the action of stress. So these are the patterns or cracks that we see on walls or on glasses that is about to shatter, and also in fields during El Nino or dry season. Then we have animal stripes and spots. This can be series of bands or stripes or even spots, often with the same width, color, or length, like zebra stripes, leopard dots, honeycombs and band of clouds, uh, and many more. Okay. Then last one is the bubble pattern. So these are round spherical because of what we call surface tension, wherein a force that would pull water molecules together on the tightest possible or closest possible groupings. Okay, so that is how bubble is created. Now, if bubbles have created in bigger scale, we call it foams already. Okay, so we have the idea of minimum surface tension. That is because of the or minimum surface, smallest area that can be occupied with maximum occupancy. Okay, so these are the seven patterns that we can see, the common patterns: symmetry, fractals, tessellations, stripes and spots, and even bubbles. So this is lesson 1.2 or less on 1.2. Yes, thank you so much and have a great day.